Welcome, everyone. Hope you guys are having a wonderful day. Get to spend a little bit of time with me. Keep this pretty laid back. Ask as many questions as you want. This is kind of a way to get the discussion started about what we're seeing from a manufacturing using laser scanning in that realm of the world. So diving in, again, a little bit about Imagine It. We are RAND Worldwide umbrella. There's four major groups, but we represent a lot of hardware and technology, a lot of software. We are a core Leica dealer. We are also Epic Games. The reason why I point those two out predominantly is because that's what we're going to talk about today. How do I take laser scanning and implement it into my everyday workflow? We'll talk a little bit about the Autodesk and the tools we can use for that, but also looking at Epic Games. I want to see how my building looks from maybe AR, VR. What can we do from that standpoint? So again, diving into this, a little bit about me. I've been in this industry 29 years. I don't know it all. I don't want to know it all, but I know a lot. If you have questions and I don't know, I have no problem telling you I don't know. We're all human. So like I said, ask me anything. Certified Autodesk instructor. Been doing reality capture laser scanning for a little bit more than 15 years now. Just generally love what I do. I get to play with this technology day in, day out, and continue learning as much as I can. So looking at today, a couple things I want to hit on is reality capture, what and why. Not everybody is maybe familiar with what reality capture is, how we use it in our day-to-day, why we use it. Then I want to talk about some manufacturing workflows, and then you guys can read the captions. Reality during construction. How do we use a reality capture to improve coordination, collaboration? I know that's a big one. But then kind of the thing at the end is where we see it going. We are pretty unique in the sense that we're Autodesk's largest partner. We're also Leica's largest partner. How do we see these two being merged? How are we seeing clients utilize this information, this point cloud data, this modeling? What are we doing with that information? So first off, why, what are different ways that we can use reality capture? What is reality capture? It's a question that a lot of people ask as soon as they understand that what I do for a living. They go, what is reality capture? Well, it's kind of funny, but it's the art of capturing what's there. There's so many different ways to do it. I could use a drone. I could use your iPhone. I could use a camera. I could use LiDAR scanning. I could use SLAM scanning. I could use aerial LiDAR. There's just so many different ways to capture data. Just like having a toolbox. How many different tools do you have in that toolbox? How many screwdrivers do you have? I don't think I've ever met anybody that has just one screwdriver. It's multiple. All different scanners, all different, photogrammetry, bathymetrics. And this is all capturing what is there. Now, how can it help us? Why, what are some of the reasons we do reality capture? I've kind of gone through and documented, 6 or 7 of these. Informed design. I go out. There's so many different ways. I've got existing facility. I scan it. I need to create a set of drawings from that, whether it's 2D or 3D. I've got clash detection, utilizing the point cloud data that is captured from whether it's photogrammetry or whatever device we're using, taking that, overlaying it with the model, doing a clash to see if my piping or my conveyor system or whatever I'm designing from point A to point B can get to point A to point B. So, virtually comparing as-built conditions point cloud with the new model. One of the things that is very near and dear to me is validating as-builts. All right. From a manufacturing standpoint, that building's probably being modified, or the production line or the piping or the conveyor system, they're always being tweaked to make our service better, that workflow better. How many of you are going out and actually documenting all those changes? Probably some, but slim to none. I mean, let's be honest. We try, but at some point we just get overwhelmed and we just don't have time to keep up. So to me, validating as-builts is a huge, huge advantage of laser scanning and point clouds. Then we get into if we're doing, some monitoring or getting into cultural or heritage. I know that's not a lot of manufacturing. There are some manufacturing sites that are historical buildings. They're super old. They want to maintain that. All right, well, let's go field measure that. All right, best way to do it is laser scanning, because now I have a documented a digital image of what's there. The other in this list of 7 that really stand out to me that's very important is probably number 1. It's tied for number 1, number 2 on the list is document construction processes. Why is this important? Like I said earlier, we're always making modifications to buildings. We're always making modifications to production lines. We're always making modifications to piping, mechanical rooms, always. So one of the ways that we can keep track of that is simply by laser scanning, keeping that laser scan. That's a factual document that we can prove where that data is at. So, it's kind of a 1,000-foot overview of what and why. But now we want to get into, different manufacturing workflows. All right. And I like this image. I use it a lot. If anybody's been on our imagineit.com website and you've looked under reality capture, guarantee you've seen this. Reason being is looking at where point clouds have come, okay? The clarity of them, the accuracy of the data, it has come a long way, all right? Now, if you look on the left, this is the photograph that was taken at the time of the scan, which is on the left. The photograph's on the left, the scan's on the right. Right? Look at the clarity of the photograph. Leica has come a long way with making their photographs a lot more crisp, a lot more clean. But look at the point cloud on the right. That is as realistic of a point cloud as you can get. And I'm telling you, I'm not one to make things all fluff and pretty. This was taken without any cleanup. All right. I like showing reality. Could I go in there and clean it up and make it look even better? Absolutely. Should you? Maybe. But at the end of the day, looking at the point cloud, I'm now able to take that into, AutoCAD, into Revit, into Inventor, into SolidWorks, and be able to utilize tools in those softwares to start extracting geometry from that point cloud. How much does that enhance and make our process for creating existing conditions easier? Now, let me tell you, being truthful, there's no easy button. I can't just hit a red button that says easy and everything comes out and it's all done. There is no such thing. There are tools that will help us do that. You know, grabbing the horizontal and vertical pipings, putting in the elbows, putting in the structural, putting in the walls, the doors, the windows, the floors, the concrete structure. There are, let me start over from that one. There are a lot of tools that will assist me in doing that. That helps us a tremendous amount. Now, this is just one example of what we can do and what that point cloud data is going to look like when we bring it into all these different softwares. So what else can we use this data? Just to throw out a few, mechanical rooms, fuel, oil, and gas refineries. We do a lot of refinery work with laser scannings. You know, one of the things is equipment layout. They'll scan the entire facility, go back and look at the current layout, use that point cloud data to relay out equipment. So there's a lot of different ways from a manufacturing that we can to use this point cloud data. Now, let me pause for a second, because one of the things I want to point out and make sure that we're all understanding is I always get asked this question at some point, whether it's during the presentation or after. I'll get an email. Well, I've got this really old part. We don't have any drawings for that part. Can I laser scan it? The answer is yes, you absolutely can. Okay. But we have to be very careful about what type of equipment that we use. Okay. Kind of what I'm talking about today is from the building, the equipment layout, the floor layout realm of our industry. Okay. That is, you know, LiDAR scanning, where we're getting accuracies down to a 1/16 of an inch. We're getting, you know, a range of 130 meters or 390-ish feet. When we start looking at the other side of the spectrum, where I've got to get sub-millimeter accuracy, that's getting into a little bit different laser scanning. That's called reverse engineering. All right. And that's where we get into our arms, tracking arms, tracking scanners. Using that equipment, that's going to get me down to sub-millimeter accuracy. Okay. It is two completely different worlds. A gentleman years and years and years ago, when I first got into this, he said, if you start looking at reverse engineering, you know, creating parts, sub-millimeter accuracy, and creating a building with laser scans, we're talking about a chainsaw or a scalpel. Two different tools. They both cut, but what's your accuracy? How fine do you want to cut? So I know that's kind of comical, and you know, but it has always stuck out to me. You know, if we want a scalpel, then we're doing reverse engineering. So that's really tight, really, really, really fine detail. Moving on to looking at it from while the, you know, our facilities being built. What are some of the things that how can we utilize laser scanning during construction? Well, there's a lot of stuff that goes inside walls. There's a lot of stuff that goes inside concrete decks. You know, there's always, if it's a multi-story building, you're always going to have rebar, structural steel. Why don't we get that all scanned before the slab is poured, or before that wall is completed, before that structural column is poured? That way, if I need to mount a jib crane or some type of crane from that column, you know, 10 years from now, I can always look at that data, see what's in that column, or see what's in that wall, or see what's in that floor, know exactly where the conduit or the pipe sleeves or pipe, say there's some type of piping system running in the slab. I know where all of that is. It's documenting that as-built condition. All right. That is extremely valuable. All right. The other thing I want to mention here is, there's a big buzzword, digital twin. All right. Laser scanning is not a digital twin. Laser scanning is a means and methods to start establishing a digital twin. It is a method to, I can go out, I can laser scan, I can come back to the office, I can accurately 3D model that building and put those assets in my model. For instance, all the conduit. If you notice over here on the top left picture, you see there's looks like a conduit duct bank coming up. I know where that's at. All right. I can now come back and accurately put those in my model. Pipe sleeves. I want to check my pipe sleeves. How many times have we gone out to a job site? We're building this multi-million-dollar building, and the contractor puts in pipe sleeves and they're off 6, 8, 10 inches. Well, that's no big deal. I can just move the pipe 6, 8, 10 inches. Well, but what does that do downstream? What does that do upstream? Moving that pipe to meet that could cost several thousands of dollars in the long run. Or during construction, before the pour of the pad, I can do a quick pour or do a quick scan. And with the Leica scanner, it takes about 28, we'll round up, we'll call it 30 seconds to do a scan, and about 5 minutes to bring that in, to overlay it, to do a sleeve analysis. Is that sleeve in the right location? Yes or no? And if I can move the sleeve before it's poured, it's a couple $100 based off past experience last year. So, during construction, keeping the contractor honest, I guess, is a word we could use. Making sure that they're putting in where they're supposed to be putting it in. Documenting what's there. That way, if I have to go back and do a core drill a year or two from now, I know exactly where all that conduit, all that rebar, existing parts are in that slab. Another one, floor flatness. This kind of ties into the existing conditions. Making sure that I'm double checking the pour, I'm double checking, I'm recording all of those as-built conditions before they pour it. Now I've got a record drawing of that. More importantly is we got to make sure our floor is flat. Is the floor ever going to be perfectly flat? Now we'll get it very, 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 very close. But knowing, a lot of the equipment, some equipment has some play where I can adjust feet. Some says no, it has to be within a tolerance. We do a lot of education for hospitals, for customers that work for hospitals, and they go, man, you've got all these specialized medical devices. They have a floor flatness tolerance. Up until about 8 years ago, I didn't realize that there's actually a business that they go around, and once the floor is poured, they do floor flatness for hospitals to ensure that they are meeting the spec for the MRI, the CT machines, the X-ray machines, all that equipment, because they have a tolerance. So floor flatness, if you have equipment, I'm not going to drop names, but there's a food grade spice company. I guess it would be food grade if it was spice, but spices, where they have robots that transfer material from one place to another, to another, to another until it's all done. Well, their robots have to be within a tolerance. That floor has to be within a tolerance so that they can navigate correctly. Floor flatness become a really, really important deal. They were doing it by hand. I'm like, man, you guys can do it so much faster with a scanner. And they're like, yeah, there's no way. Well, they cut their time in way more than like over 75% of the time savings. Pay for a scanner on the first job. Now they only laser scan floors to do their floor flatness for their customers. Again, going back to, I have a tendency to do this, but I kind of jump the gun. Talk about, documentation of as-built during construction. This is a great example. I know where the sanitary piping is. I know where the conduit is. I know where the rebar is. I know everything there is possibly to know that's inside that slab. I cannot argue that because the laser scanning captured all of that data. Now, I do not have pictures turned on in this particular scan just because it was kind of dark and I wanted to really reflect and see how that point cloud looks. But again, just having this data, that's going to minimize risk. Because now I'm not going, well, I think I can drill here. That whole bang to fit, paint to match thing doesn't really work a lot of times. It doesn't end so well. So we want to try to mitigate that risk by laser scanning and keeping that archive. Moving on, this is something that we've really gotten into on a manufacturer side quite a bit. It's become very, very prevalent that manufacturers are going, hey, we're making this product. What can we do to make it better? How can we make it better? How can we make it faster? How can we streamline our flow? So one of the ways that we are seeing this is clients are going in, they've got all their existing conditions. They got all their equipment. They go in, they scan around every piece of equipment. They scan their entire building. They scan everything so that they can see and have documentation of what is actually there. All right. This case in point that you're seeing here, this was a tool and die shop. It was a very, very large shop. And what they wanted to do is they had all this equipment, but it was in no real workflow, process flow. Looking at the image I have here, some of this equipment created an item, an object that had to be carted over to the other side of the warehouse to be worked on. And then they had to move it back to be worked on again. So what they did was, to maximize efficiency, they scanned the whole facility. They went in and created, using Autodesk software like Recap, and they took each piece of equipment, because it's a three-dimensional point cloud. They took each piece of equipment and saved it out as a asset, a Recap asset. At that point, they were able to create an existing condition 3D model of the building. They then were able to take each one of those pieces, those point clouds that were a piece of equipment. They were named very specifically. This is model XYZ lathe or press or whatever. They were able to take and start laying this equipment out without having to remodel all of that existing equipment, and be able to accurately start relaying out the equipment to match the floor space that they had, putting like processes together to minimize all the inefficiencies that they had before. They ended up doing this on all 11 of their facilities. they increase their productivity substantially. What's that number? Never heard it, but I was told substantially. So, being able to go in here to reorient, maximize the space, get the equipment, and somebody says, well, why don't you just create a box? Well, we could, but again, if I can take a 3D scan of that piece of equipment, I see all the conduit coming off. I know, what that conduit height needs to be. I can actually take that, lay that out, see my vertical, horizontal, all of that in one swoop. And all I'm doing is creating just basically an asset, or for lack of better terms, like a block. Right? I don't have to go in and remodel it all. Uh-oh, I think I froze up. There we go. The next one is another area that is near and dear to my heart, and sometimes coordination, collaboration can be considered dirty words. Again, been in this industry 29 years. I've seen coordination turn ugly. I've seen coordination turn beautiful. So, it's the best of both worlds. One of the things that, again, I said it before, I'll say it again. Point clouds are not a digital twin. It's the means and methods of starting to create that digital twin. All right. And, maybe we're not getting into digital twin yet. I think you should. I think we should work that way. But one of the things that I dearly love is not all of our owners, operators can visualize what 2D looks like. They look at a set of prints and go, yep, that pipe goes from there to there. But what happens between point A and point B, point C, point D, point E? What does that look like? So now let's take a step back. I go out and laser scan the existing conditions. All right. I need to route piping from point A to point B, or I need to route a conveyor from point A to point B, or I need whatever it may be. I got to get from point A to point B. Now, with what we are able to do with laser scanning, we bring that into AutoCAD architecture, Revit architecture, Revit MEP, SolidWorks, Inventor, MicroStation, Plant 3D. Try to cover all the bases there. Pretty much any piece of software I can get a point cloud into. Now I utilize that point cloud to route my new work. What am I doing? Why am I doing that? Coordination, collaboration. I'm now routing my new work piping based off the existing conditions. Are point clouds very accurate? Absolutely. Do I trust it more than, John Doe or Jane Doe going out and pulling a tape measure? More than 100% yes. Because chances are, if you're field measuring, you're not getting every single dimension, every single measurement, every single angle that you want. With laser scanning, you're probably not getting every angle you want, but because I move the scanner around, I'm scanning from multiple locations, I'm getting data that you don't know that you need. I'm getting data that I do need. But it's when you get back to the office and you go, man, I wonder what the bottom of that pipe is, or I wonder what the bottom of that conveyor is. I didn't get that. I guess I got to go back out. Well, no. If we scan it correctly and we do, what we're supposed to and how we're supposed to, generally speaking, you should only have to go to the site one time. I know this particular company, it's a Canadian company, got permission to use this. They said that they do a lot of food processing, a lot of oil and gas and things like that. And they are telling me that where they would used to take 2, 3, 4 people, now they're taking one person, what used to take them 2 or 3, 4 days to measure, now they're sending one person on an airplane, laser scanning it, and coming home that night. What's the average person? What are you spending a day to send one person to a job site 2 states away, or even down the street? How much time could you be saving? So by doing this, by taking the existing conditions, the point cloud, being able to overlay the 3-dimensional model, I'm able to publish that out and give that to the client. Say, hey, Mr. Client, take a look at this. This is what this is going to look like. We were concerned in this area about bottom of pipe elevation or bottom of elevation of the conveyor. Look, Mr. Client, this is what this is actually going to look like. I can do a fly through, and all of that is all done inside the point cloud software. So it is a big, big, big deal. Lastly, we'll dive into, and I'm just going to spend a few minutes on this because where we see this going, man, it's a wide open racetrack. What do I mean by that? We see so much technology opportunity to make our jobs easier. You'll notice I got Spot, the Boston Dynamics robot. I think there's 6 or 8 different manufacturers now, but there are companies, very, very, very large companies, car manufacturers, that go, hey, we want to continuously scan and monitor our buildings. So one of the things we're kind of seeing is these robots being able to strap a scanner to its back, set it up, park it in a corner every night at a certain time. The robot gets up, it walks itself to the path that the person designated. They do the laser scans, they come back, the data downloads, and it's ready to go in the morning when you get there. That's pretty sweet. I'm not going to lie. I would love to have one, probably freak out the neighbors a little bit, but it'd be so cool to have. We see a lot of this information. The big thing that we're seeing is a push toward digital twins. The more information we can capture, the more accurately we can build these existing models, the more accurately we can utilize the digital twin. Softwares like Tandem, being able to put in the IoT sensors, monitor equipment, monitor, whether lights are on, occupancies. We can now start utilizing that digital twin to turn off lights, to control the building, get readings from equipment. If a fan motor is running at X and it starts to have problems, the report's going to tell us, hey, you're starting to lose some efficiency here. You may want to go check that out. So there's a lot we can do. We see that a lot more manufacturers are getting into the laser scanning for as-built conditions, for the digital twin, for asset management, just seeing what's there. It's a cool technology, and I think it does have a place for most manufacturing locations. Not all. I live in reality. It's not for everybody, but it is for